Next, let's look back to the internal fragmentation problem. So before we go through the details, let's look at a real-world example. Suppose we have a process with size 72766 bytes at the right corner of this slice, and the page size is 2048 bytes. So in order to hold the entire process on the main memory, so we need 35 full pages plus one more page to hold the rest bytes of the process, which is 1086 bytes. So therefore, for the last page, it will waste 2048 minus 1086, which is equals to 962 bytes. So we will waste this much of bytes. It is not an ignorable amount of memory. According to the statistic results, the average wasted internal fragmentation is about half of the frame size. So how can we decrease the memory wastage? So some researchers may say that, can we just make the frame size as small as possible, since the average wasted memory for each process is half of frame size. So if we decrease the size of the frame, then we can shrink the wasted memory as well. However, one thing we need to be careful is that, we need to use a page table to hold the mapping information for each process. So if we decrease the size of a frame or a page, the number of page table entry will be increased at the same time. We also need to use the main memory to hold the page table for each process. Therefore, it may not be a good idea if we just decrease the size of a frame. And actually, as the development of a computer technology, the page size are growing over time. So due to the size of a main memory gets increased, and also the size of a process becomes larger and larger. So therefore, some of nowadays operating systems, they support multiple page sizes. For example, Solaris operating system can support 2 page sizes, 8 KB and 4 megabytes. So when the size of a process is small, so you can choose 8 KB page size to decrease the wasted memory. If the process is too large, so you can use a 4 megabytes page size to shrink the size of a page table. And also, as we already mentioned in the previous slide, the process will of memory and the physical memory now can be very different. So from the perspective of a process will, the memory is a logical memory space. The entire process is stored at a contiguous memory location. On the other hand, the physical will of a memory is very different, because all of the frames for a single process are scattered among the physical memory space and out of orders. Next, let's see how can we allocate the free frames to a newly arrived process. So when a new process arrives to the system, so we first check that whether the number of free frames are enough to hold the new process. For this example, we know that the new process includes 4 pages. So since we have 5 free frames on the list, it is large enough to hold the new process on the main memory. Then we just add the new entries on the page table to map the logical memory to physical memory. For the first page 0, it can be mapped to frame 14, page 1 to 13, page 2 to 18, and page 3 to 20. Again, from this example, it further indicates the different will between logical memory and physical memory.